Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the antiderivative of a radical function. For this video, we have here a radical function, square root of x. So we have here the integral of square root of x dx. This is a radical function because it has a square root symbol. Okay, even if it's cube root, it's also a radical function. But there is one thing that we would like to discuss first before providing you with the answer for this. Now, this is discussed together with the polynomial functions because this example in the next few will use the power rule as well. But that is only true if the radicand, we know that the radicand is the expression inside the root symbol, is actually monomial. If the radicand is not monomial, then there is a specific and another rule in providing or solving for the antiderivative of a certain radical function where the radicand is a binomial or trinomial expression. We will have that later on. But since our given here, the radicand is a monomial x, so we can use here the power rule itself. This because we know that square root of x is just equivalent to x to the power of 1/2. Okay? Where our 1 is the exponent of your radicand and 2 is the index. Okay, we know that already when we try to transform a radical expression into an expression with a fractional exponent or vice versa. So this is just equivalent to the square root of x to the power of, the integral of x to the power of 1/2 dx. And with this now, it fits the criteria of the power rule, which tells us the integral of x to the power of n dx, where n is not equal to -1. In this case, it's just 1/2, which is actually equivalent to x to the power of n plus 1 over n plus 1 plus c. That is why this specific example of a radical function is discussed right after the concepts for polynomial functions, which uses the same power rule. Now, for this, since it fits the criteria, this is just equivalent to the power rule now, x to the power of 1/2 plus 1 over 1/2 plus 1. Then you will have here plus c as arbitrary constant. Now, when we proceed with our expression here, that's just equivalent to x to the power of 3/2 because that's 1/2 plus 1 over 3/2 plus c. The other purpose for this is, of course, to review other forms of rational expressions because we have here a rational denominator, and of course the conversion of this fractional exponent into another expression which uses root symbol. We know that x to the power of 3/2 using this rule would be equivalent to x to the power, you will have here the square root because that's the index of x cubed over 3/2 plus c. Now, since this is actually a fractional denominator, we can use its reciprocal. This is equivalent to 2/3 square root of x cubed plus c. Now, for some cases, this is already acceptable. But since we have here a possibility of simplifying the radicand because our index is just 2 and the exponent of our radicand exceeds 2, so this is just equivalent to 2/3 x square root of x plus c, as we have here square root of x squared times x, and that can be simplified as x square root of x and plus c. This is now the antiderivative of our given radical function, which is different from the previous examples because we are now dealing with fractional exponents and possibility of fractional denominator which needs reciprocation. So try to find the derivative of this. If it returns to this form, x to the power of 1/2 or square root of x, and that means our answer is correct. Thank you very much for watching. So what are you waiting for? Subscribe now!